Alright, so today we're going to look at using algebra tiles. For the sake of the overhead transparencies, I use blue as negative tiles and red ones as positive tiles, but I don't think that'll apply too much in your notes here. So first off, we're going to look at just a quick recap here of what the tiles look like. There's a big square that's an x squared tile. There's a long rectangle that's the x tile, and there's a small square that's the units tile. For purposes of drawing them, I usually draw a small square to represent x squared, just a line to represent x, and a dot to represent the units or the ones. Positives are as you see them, negatives are the same, but I just put a slash through them. So how would I represent 2x squared plus 3x plus 2? 2 squares, 3 lines, 2 dots. Bada bing, those are my tiles. Now, if I want to show x plus 2, let's see, what was I doing here? X plus 2 and x minus 4. Alright, if I want to multiply x plus 2 and x minus 4, to do that, I create a frame using those tiles. So I've got an x and 2 units, I've got an x and 4 negative units. The expression that fills in the rectangle perfectly will be the result. So x times x, for example, is an x squared tile. X times the 2 ones are going to give me 2 x tiles. Negative x's down on the left, and then negative 1's in the middle. A positive 1 times a negative 1 equals a negative 1. If I look at the tiles, I've got 2 x's, I've got negative 4 x's, I've got negative 8. I combine my like terms and I get x squared minus 2x minus 8. Let's say on the other hand that we want to show x squared plus 5x plus 6. And we want to factor it, or we want to represent that as something that's factorable, then we have to place those tiles so that they fit in a rectangle. So you'll notice I have x squared plus 5x over to the right, and then if I show my 6 units, I can't get that 1 to fit in anywhere, and I'm missing an x tile. If, on the other hand, I show x plus 2 and x plus 3, I get 2 x's on the right, 3 x's down below, and I've got the perfect amount of space for my 6 unit tiles. The dimensions of the rectangle become the factors of that trinomial, x plus 2 and x plus 3. Remember that when we learn to factor, we look for 2 numbers that multiply to give 6 and add to give 5. 2 and 3 work, x plus 2 and x plus 3. So if we look at x squared minus 2x minus 3, you can disregard the red and the blue part there. Oh, not sure what happened. Oh, I must have been doing something on the board. Alright, so let's just pause here. Okay, in this situation, these are questions from the book, not using algebra tiles anymore, and we're looking for some unknown value of b. So the question says, determine 2 values of b that allow the expression to be factored. Well, we know from what we learned about factoring that when we look for the factors of a trinomial like this, where the a value in front of x squared is 1, we look for 2 numbers that multiply to give 12 and add to give whatever the b term is. So if I find all the numbers that multiply to give 12, like 1 and 18, 2 and 9, 3 and 6, I don't need the negative numbers because I know that b is positive. If I add those pairs, I get 19. 2 and 9 add up to 11, and 3 and 6 add up to 9. All 3 of those values could go in the place of b. So I could have x squared plus 19x plus 18, x squared plus 11x plus 18, x squared plus 9x plus 18, and all of those would allow the expression to be factored. So b could be 19, 11, or 9. Now there's a different style of question where we're looking for 2 values of c that allow the expression to be factored. So I might have x squared plus 5x plus c. I know I'm looking for 2 numbers that multiply to give c and add to give 5. Notice that c is positive. Okay, so we're looking for values of c, positive values of c. So I'm looking for two numbers that add to give 5 that will have a positive product. For instance, 1 and 4, or 2 and 3. Heck, even 0 and 5 add up to give C. Now we want there to be a C value, so I'm not going to use the 0 and the 5. But I could use 4 and I could use 6 as values of C. So x squared plus 5x plus 4 or x squared plus 5x plus 6 would be factorable. Okay, there's your assignment, 9 to 12 on page 235. Work on those, good luck with them, and hopefully this video was useful to you. Bye-bye.